How about we tune the telescope into universes being conceived? And goodness, my golly, who requested this? We're tracking down cosmic systems in obscurity ages. However long logical request has dug into the beginnings of our universe, the predominant clarification has been the theory of the universe's origin. Incalculable studies and the cooperative endeavors of large numbers of researchers have supported this hypothesis, giving significant proof for how the universe came into being. Anyway, the scene of science today is extraordinarily unique in relation to that of the past. Mechanical headways consistently introduce new speculations and points of view, testing what we once thought about undeniable insights. In this developing logical scene, where new disclosures reshape how we might interpret the universe, Neil deGrasse Tyson has become a noticeable voice. Now, a noteworthy advancement has become exposed, as the James Webb Space Telescope has uncovered a discovery that raises doubt about the well-established theory of the universe's origin. This revelation includes the location of an amazing 750 new worlds, each of which overcomes our past presumption of what worlds ought to be like. By the way, the James Webb Space Telescope was considered and intended to help us figure out the beginning of cosmic systems, so we ought not be astonished that it's leading us to scratch our heads. Join us as we investigate how the new pictures from the JWST expose the theory of prehistoric cosmic detonation. With the discovery of 750 new systems, researchers have advanced the theory of prehistoric cosmic detonation as the main clarification for the beginning of our tremendous universe. As per this hypothesis, around quite a while back, the universe appeared through a strange grandiose occasion of some kind. It's a definitive birth story of the universe. The amazing idea of the pictures caught by the James Webb Space Telescope has tested researchers' comprehension of the universe's starting points. The speculation that these pictures straightforwardly go against is the Big Bang speculation, which has for some time been respected as an obvious truth by the greater part of cosmological scholars. These systems give off an impression of being too little, too smooth, too old, and too various when contrasted with the eye of the Big Bang speculation. The little size of the noticed systems totally goes against the normal conduct in a growing universe, as indicated by the speculation. As the universe grows, items ought to seem bigger with expanding distance. As per the theory of the universe's origin, at the earliest reference point of the universe, all matter, energy, and the structure blocks of the cosmos were packed into an incredibly little and exceptionally focused point. This point is known as a peculiarity. Inside the peculiarity, all the matter and energy in the universe existed in a phenomenally packed structure. The outrageous thickness infers that a tremendous measure of mass and energy was concentrated inside an imperceptibly little space. The temperature inside the peculiarity would surpass any temperature that can be noticed or duplicated in our ongoing comprehension of the universe. The energy put away within this hot, thick point was the seed from which the whole universe would unfurl. Extension. That is the reason the peculiarity marked the start of the universe as we know it. It was the beginning from which all that in our universe came. After the introductory peculiarity, the universe began the excursion of development and expansion. This interaction happened throughout the span of roughly 13.7 billion years, forming the universe as far as we might be concerned today. The extension of the universe began with a remarkable explosion of quick extension known as infinite expansion. During this stage, the universe extended at an unbelievable rate, far surpassing the speed of light. It resembles the texture of space itself was extending and extending, taking everything inside it. Curious to see what happens? Inestimable expansion assumed an enormous part in forming the huge scope design of the universe. Its streamlined abnormalities homogenized the conveyance of issue and energy, and set up for the resulting development of cosmic systems, stars, and other enormous designs. As the universe kept on growing, the pace of development progressively dialed back. Yet, with this data, it means quite a bit to note that despite the fact that the underlying time of infinite expansion finished, the universe kept on growing at a quantifiable rate. This continuous development is known as the extension of the universe or grandiose extension. Researchers have noticed the impacts of this extension through different perceptions, like the red shift of light from far-off cosmic systems. The red shift demonstrates that as the universe extends, light waves get extended and shift towards longer frequencies, moving them towards the red finish of the range. We'll dive into the subtleties of this later on in the video. From the get-go, look, the pictures of the new systems that were taken by the JWST look totally stunning. Positively, you can see many systems all in a similar casing, and the sheer power in the photographs is something you just can't overlook. Yet, that is what things resemble to the typical individual. For analysts, things are the inverse. These pictures are astonishing, to say the least. They don't match researchers' thought process they would see in view of their hypotheses. They're seeing far more cosmic systems, in fact, than anticipated, and these cosmic systems are different in a few amazing ways. They're smooth, more modest than envisioned, and truly old. This large number of amazements are causing somewhat of a frenzy among the researchers. One paper even begins with the word alarm in its title, so you know things are serious. The systems seem to be something they shouldn't. The age of the noticed cosmic systems is by all accounts staggeringly abnormal. Here, the JWST perceptions demonstrate the presence of worlds that give off an impression of being out of the blue old. This challenges the normal course of events of cosmic system arrangement and advancement inside the structure of the theory of prehistoric cosmic detonation. In addition, there's likewise the way that the wealth of noticed cosmic systems is a great deal higher than whatever should be. The Big Bang speculation predicts a certain circulation and thickness of cosmic systems in view of the extension and advancement of the universe. However, the JWST pictures show a gigantic number of universes, which raises inquiries regarding the precision of the forecasts made by the speculation. There's likewise the way that the perfection of these cosmic systems is completely unforeseen. The theory of the universe's origin proposes that cosmic systems ought to show abnormality and varieties in their structures because of the elements of their arrangement and development. Anyway, the JWST pictures uncover worlds that show up curiously smooth, coming up short on the anticipated degree of intricacy and, typically, roughness which one would expect to see as indicated by the Big Bang nucleosynthesis hypothesis. While the extension was going on, we fundamentally had all the stuff that makes up our universe fit into a tiny volume. Obviously, matter proved unable to make do in space like this, so something needed to give. As the universe extended and chilled off, changes occurred. Particles like protons, neutrons, and electrons began to interface with light and energy in their environmental factors. These cooperations assumed a vital part in molding the development of issue in the universe during the initial couple of moments after the Big Bang. There was a cycle called nucleosynthesis. This cycle included the production of lightweight components like hydrogen and helium. The limit temperatures and energy during this stage took into account the combination of protons and neutrons to frame these basic nuclear building blocks. Hydrogen, the least complex and most bountiful component in the universe, was shaped fundamentally during this early period. Helium, the second generally bountiful component, likewise arose during this time. These components were instrumental in making way for the arrangement of stars, systems, and more mind-boggling components that would come later in grandiose history. The blend of these natural components was an important achievement in the advancement of the universe. From an early-stage ocean of particles and energy, the early universe changed into a state where matter in reality began to come to fruition. This process established the groundwork for the rich variety of issue and the immense grandiose structures that ultimately came into being. Presently, the Big Bang scholars themselves expected to notice systems that were damaged and mixed because of numerous crashes. Anyway, the JWST pictures present an alternate story. Rather than tumultuous and rumpled cosmic systems, the pictures uncover predominantly smooth plates and efficient winding structures, looking like the universe we find in the current-day universe. This surprising perception challenges the idea that consolidations are a normal cycle in the advancement of universes, since obviously these new universes haven't gone through any of the difficulties that you'd ordinarily anticipate assuming you were following the Big Bang hypothesis. On the off chance that there are only a couple or, on the other hand, no consolidations occurring out there, it becomes unlikely for small worlds to develop and become many times bigger. This infers that these universes were never initially minuscule in the first place. Alongside it, the optical deception anticipated by the extending universe speculation, where items seem more modest with expanding distance due to extension, likewise doesn't exist. As space experts have fastidiously noticed and planned the universe, they have found a striking example: the bunching of worlds and the by and large construction of the universe. Worlds tend to assemble together in tremendous gatherings, groups, and superclusters, framing complex organizations that stretch out across the universe. This noticed huge scope structure lines up with the expectations made by the theory of the universe's origin. As indicated by the hypothesis, the universe started as an extraordinarily thick and hot state, and over time it extended and cooled. As the universe extended, gravity played an urgent job in molding the dispersion of issue and the arrangement of cosmic systems. The gravitational impacts anticipated by the theory of prehistoric cosmic detonation are steady with what we notice today. Gravity draws matter together, making cosmic systems group in specific districts and structure filamentary structures that associate them. These designs uncover the astronomical web-like example of the universe. The presence of these universe groups and the interconnected snare of issue offers solid help for the Big Bang hypothesis. The arrangement of systems and their conveyance across the universe lines up with the gravitational impacts anticipated from the underlying thick and growing state posited by the hypothesis. At the point when you look again at the size of the systems the James Webb Space Telescope found, you can truly perceive how the pictures depict a totally different reality from what we thought was our world. As indicated by Big Bang scholars, these little worlds develop and advance into the bigger universes we notice today through a course of impacts and consolidations. To make it simpler to contemplate this theoretical situation, you can contemplate the individual universes as an assortment of stars and dull matter that are kept together by gravity. In this present circumstance, at the point when two worlds come into close contact with each other, their gravitational fields communicate with one another and revise the stars and gas inside the galaxies. If the systems indeed impacted, the consolidation would bring about the arrangement of new stars and increment the size of the recently joined cosmic system. We call this course of combining cosmic nucleosynthesis, and as indicated by the theory of prehistoric cosmic detonation, it is accepted that these little systems would have gone through various consolidations over billions of years to frame the enormous winding and curved cosmic systems that we see today. Anyway, the universes noticed by the James Webb Space Telescope, JWST, tested this thought. The systems found by the telescope are shockingly little, smooth, and apparently old, challenging the assumptions set by the theory of prehistoric cosmic detonation. The pictures caught by the JWST uncover a populace of worlds that are a lot more modest and smoother than expected, raising inquiries regarding the legitimacy of the current cosmological models. The beginning and development of these cosmic systems show up to go against the forecasts made by the theory of the universe's origin, which posits that universes ought to advance through consolidations and crashes over the long run, rather than the tumultuous and unpredictable structures anticipated from cosmic consolidations. The universes seen by the JWST display clear-cut, smooth shapes suggestive of current worlds. This surprising disclosure challenges our comprehension of how cosmic systems structure and develop inside the structure of the Big Bang hypothesis. Besides, the age of these newfound worlds is moreover puzzling. The JWST perceptions propose that these worlds shaped significantly sooner in astronomical history than beforehand thought conceivable. This disclosure raises basic inquiries regarding the course of events of universe arrangement and the cycles that administer the development of the universe. Researchers are currently grappling with the ramifications of these discoveries and are attempting to amend existing hypotheses to oblige the new perceptions. The disclosure made by the JWST has opened up new roads of research and has ignited a restored interest in understanding the early universe and the development of cosmic systems. In synopsis, the pictures caught by the James Webb Space Telescope challenge the winning speculations of cosmology, especially the theory of the universe's origin, by uncovering a populace of suddenly little, smooth, and old cosmic systems. These discoveries feature the powerful idea of logical request and the non-stop development of how we might interpret the universe. As researchers dig further into these secrets, they make certain to reveal more amazements and further refine our astronomical account. The revelations made by the James Webb Space Telescope, JWST, have lighted a lively discussion among cosmologists and astrophysicists with respect to major hypotheses that oversee how we might interpret the universe. One of the most striking parts of the JWST perceptions is the sheer number and variety of universes it has uncovered. These universes not just challenge existing models of universe arrangement, yet in addition raise charming inquiries regarding the hidden physical science and processes at play during the early epochs of the universe. One of the key puzzles introduced by the JWST discoveries is the idea of universe morphology. In contrast to the unpredictable and divided systems anticipated by the various leveled combining model of universe development, the JWST pictures uncover systems with amazingly smooth and requested structures. This surprising disclosure proposes that elective systems, maybe including more steady and less vicious cycles, may have formed these worlds over grandiose time. In addition, the age distribution of the cosmic systems seen by JWST represents one more problem. A portion of these universes give off an impression of being a lot more established than expected, challenging the customary course of events of universe advancement. This error infers that our current comprehension of the beginning phases of cosmic system arrangement might require critical amendment to oblige these new perceptions. The James Webb Space Telescope's capacity to identify and examine worlds at uncommon distances and goals has likewise shed light on the different populations of celestial objects within these systems. By concentrating on the tones and spectra of far-off worlds, cosmologists can deduce significant data about the age, structure, and star-forming history of these grandiose elements. The JWST perceptions have uncovered a rich woven artwork of star development exercises across various epochs, giving hints to the basic cycles driving cosmic system development. Moreover, the JWST's infrared abilities have permitted some researchers to test further into the astronomical past than at any other time, revealing cosmic systems that existed when the universe was just a small part of its ongoing age. These old worlds give a window into the developmental phases of cosmic development and propose insights into the conditions that won during the early stories of the universe. In conclusion, the James Webb Space Telescope has reformed how we might interpret cosmic system development and advancement by testing laid-out speculations and uncovering an abundance of new disclosures. The perceptions made by the JWST have brought up key issues about the components driving cosmic system morphology, the course of events of cosmic system development, and the nature of grandiose development itself. As researchers proceed to break down and decipher these historic perceptions, we can expect further bits of knowledge that will reshape our grandiose story and extend our comprehension of the universe's starting points and development.